This meeting is being recorded.
Hi, everyone. This is Archana Haylock with the Open Compute Project Foundation. Thank you so much for joining our Tech Talk series. Today, we are going to be talking about the data center facility, and we have a great lineup here for you. A few housekeeping things. First of all, this call is being recorded along with the chat transcript. And we will make the slides, the call recording, and the chat transcript available to you probably in the next day or so, along with the video. And if you are not speaking, we would really appreciate it if you could go on mute, primarily just to preserve the quality of the call and not distract the speakers. The speakers are gonna make their presentation, and if you have questions, you can either raise your hand or post them in the chat, and we will get to them after the speaker is done presenting. There is time for Q&A. There is time to address everyone's questions, so we are very, very excited to have a great lineup here. With that, Madhu, I think you are on, and I'll turn the reins over to you.
Thank you, Archana. Good morning, good afternoon, and good evening to everyone. My name is Madhu Iyengar, and I co-lead the data center facilities track along with Brett Lehman, working closely with Justin Steedman, who's our incubation committee lead. Just to give you a brief overview of the data center facilities project, our goal is to facilitate collaboration in the data center facility community to support the deployment of OCP racks and hardware, integrate the design and operations of the facility systems with the IT hardware, and develop innovations in a set of technologies that reduces energy consumption and cost. Hence this sustainability Tech Talk series. And we're also focusing on increasing reliability and choice in the marketplace that simplifies operations and maintenance. So we have a broad charter that covers multiple areas in the data center facility space. In terms of active work streams that we have ongoing, we have three major work streams going on right now. We have the OCP Ready Facility Recognition Program that focuses on facilities. We have a modular data center work stream that focuses on custom design, modular data centers that are becoming quite popular in the industry as a way to drive lower cost, higher efficiency, and faster velocity. And we have a operational technology and security, OTS work stream. So we have three work streams. As part of initiating new areas for us to look at, sustainability is obviously a pretty huge area globally. And in terms of data center facilities, there's a lot of interest, a lot of activity, a lot of ongoing innovation. And we have a really wonderful lineup of speakers today. I'll just go very briefly through what we have for you. I think we're really excited about this. Starting off, we have a talk on IT heat reuse fundamentals by Cosimo Pecchioli from Alfa Laval. Following that, we have a talk on accelerating green hydrogen solutions by Kajsa Dahlberg, also from Alfa Laval. And then we have a speaker from Schneider Electric, Rob Bunger, talking about a guide to environmental sustainability metrics for the data center space. Following that, we'll probably have a brief break and then start off with Gerald Thibault, focusing on data center use of HVO as an alternative to diesel fuel. Following that, there's a life cycle assessment presentation focusing on how you would calculate environmental impacts for your building. That's by Johanna Järvinen from One Click LCA. Following that, we have David Gulnazarine talking about how to decarbonize OCP data center. It's more of a broad talk on how to think about this topic holistically in terms of scopes 1, 2, and 3 that you're going to hear about more today. And then finishing up our lineup is a speaker from Google, Maud Texier, talking about 24/7 carbon-free energy by 2030, accelerating the transition to a zero carbon future. So that is our exciting lineup. I think we are ready to start the first talk with Cosimo. Cosimo, you probably have a couple more minutes if you need that. So if you want to get started and present, we can head into the technical content.
I'm ready, and thank you, Madhu, for the introduction. And let me share my screen.
I was going to say, while you're doing that, Cosimo, I've posted a couple of things on the chat for our audience. So the projects that Madhu was referencing, the 3 sub-projects under data center facilities, as well as how to subscribe to the mailing list, all of that is available on our website, and the recordings can be found also on our website. So with that, Cosimo, you are on.
Thank you very much. Thank you, Archana. And you see my screen, right?
Yep, we can.
So this is it's meant to be a very kind of short report of a work group that we have with the OCP about data center heat reuse. And we have been working, we started in January. Actually, we started at the end of last year informally, but then in January, the group was formally created, and we have bi-weekly meetings, bi-weekly calls on Tuesdays, where we discuss these matters. So again, this is not meant to actually give you any answers, to be honest with you. If anything, is supposed to actually spark a conversation that you can join our group and participate in this activity. But that being said, we have concluded that there are essentially 3 main sides when we talk about heat reuse from data centers. There are technical aspects, there are sustainability and or regulatory aspects, and then there are practical aspects. The technical aspects, as for this slide, it's pretty intuitive: how to capture the heat, measure, move it, and reuse it. And ironically enough, these are probably the easiest challenges to tackle. The sustainability and regulatory aspects are kind of geographically different. We see in Europe that regulations are popping up in different countries, like the Netherlands, Ireland, in Scandinavia, where data centers are required to show that they do at least some heat reuse. We don't see that here in the US yet, but what we see are self-imposed sustainability goals from companies, large IT companies. We all know who they are, and in order to achieve those goals, most likely some sort of heat reuse will be needed in the future. And then there are practical aspects, and these are currently probably the most challenging aspects that we have. And we will go into the details of all these 3 aspects in a minute. But essentially what we are talking about is that heat reuse implies, for the most part, that you have different actors, that you have different stakeholders. You have an IT company that operates the data center. and then you are looking for a heat reuse opportunity, heat host, we call them, and normally these are two different entities, and then in between there's most likely geographically some land that you have to cross, so there are regulations. It could be a little overwhelming at the beginning, but let's look at them one by one. So as I was mentioning before, the technical aspects, they are not as straightforward as we might think at the beginning, but they are at the end, we can solve them. You have a heat source, and then you have to move the heat from one place to another, which is something that has been done for hundreds of years. Probably the biggest comment here is that even though you have opportunity to reuse the heat regardless of the temperature that you have at to begin with, so the heat source, of course, it is significantly easier if you have a higher temperature. What I'm trying to say is that there's a quality of the heat that has a big impact on the opportunities that you have to reuse that heat. Which means that if you have a traditionally air-cooled data center or servers, that limits, let's say, the options that you have in terms of heat reuse. While if you have some sort of liquid cooling starting from rear door, and then you go all the way down to immersion cooling, normally you have the availability of higher temperatures and already in the water or in a liquid, which makes the handling and the moving on that, the management of that heat much easier. Now, with this, I don't want to say that if you have a traditionally air-cooled data center, you have no chances of heat reuse. What I'm saying is that you have less chances, but you still have some. And again, this presentation is not to give you actually any answer, it's just to show you that we are working on these options and in details. And I have a couple of slides in a few minutes where you see what we are doing. So I encourage you, if you are interested in joining our calls. The sustainability and or regulatory aspects, essentially what we are trying to say here is that in 2010, the focus of IT companies started to be directed into the source of energy. And I just put here to 2010 as the beginning of this trend, because it is when Google signed the first wholesale clean energy deal. And from that moment on, IT companies really highlighted that they are sourcing the energy as much as possible from either renewable sources, or they are buying credits to offset the energy that is not renewable. So the energy sourcing and the power was the main focus for many years. Then in 2021, actually, a new trend started, and on top of the energy focus, water consumption started to be a very important aspect. So it's kind of like we took for granted that the energy at that point was renewable or offset, but now the water consumption became a very important aspect. And we have seen communities actually pushing back data centers, new projects, because of the fear that they would use a lot of water. And they, in some cases, they do use a lot of water if you have evaporative cooling. So there is these different layers over layer of a layer of, let's say, environmental impact and sustainability that is growing. The next step that we see coming is, of course, is a heat reuse. Again, as I said, in the US, we are not there yet, but in Europe, it's definitely a reality right now. And so it would be probably preferable for the industry to be part proactively to the conversation, instead of waiting for like legislative bodies to establish what is needed to be done. And again, what I'm trying to say here is that we have a chance here to proactively reach out to the local entities, to the local government, to the state governments, even to the federal government, and say, hey, we have this opportunity. Let's work together and figure out the best way to take advantage of it instead of waiting for them to tell us what to do. That's what I'm trying to say. And again, all these aspects are discussed in details in our calls. And then, as I was mentioning before, there are practical aspects, and the practical aspects in this slide, it's a little busy, but what I'm trying to show here is that on the left, you see here, you have a data center that generates heat. And on the right here, you have opportunities for heat reuse. They could be greenhouses, they could be district energy, so district heating or district cooling. It could be industrial uses, in this case, as is desalination or wastewater treatment, it doesn't matter. But between the source of the heat and the utilization of the heat, first of all, these two are normally two very different entities, two very different companies. So I'm not aware of any IT company that owns greenhouses, for instance, or any IT company that owns a district heating network. So the coordination between these two entities alone can be a little challenging, particularly in a legislative vacuum as we have right now, where there are no rules whatsoever anywhere. And then, but in between these two entities, normally, it's not unusual that you have a utility company that somehow facilitates, if possible, this transaction. And then you might have at some point a legislative body, and in some cases it could be beneficial, or it could be actually detrimental. Again, it's kind of up to us. We have the opportunity here to manage this process, and if we don't do that, we might be in a disadvantage. So this is the landscape. This is the picture of our environment where we have our conversations. Now, just to give you a very brief example of what we talk about, this is a very summarized table of opportunities that you have based on where your data center is. So if it is in an industrial location, if it in an industrial district, if it is in an agricultural district, if it is on the sea, if it is high density urban, etc., you can see that. And these are, let's say, some heat reuse options that you have based on the location of the data center. And again, this is just meant to be a very short recap of our detailed conversation and sometimes heated conversations. And at the same time, and this is a even busier slide, but don't bear with me 1 second. I have grayed out here temperatures that are out of the reach. This is in Celsius, so temperature that definitely they don't belong to data centers. But as you can see, you have heat reuse opportunities all the way from 20 degrees Celsius, so what it is, 68, up to 100, so 212 Fahrenheit, which of course we at the moment we are far from that. But if you combine, for instance, the heat coming from a data center and you bump it up with a heat pump, you can easily, not easily, but you can reasonably think that you can reach this area here, the 50, 60 degrees Celsius. And so you have all these industrial heat reuse opportunities. And these are actually without even any bumping up of the temperature with a heat pump. Again, I don't want to sound like a broken record, but the biggest challenge that we are figuring out is not the technical aspect. It's not how to capture the heat and even how to reuse the heat. The biggest challenge that we are facing right now is to how to put these two people in the same room. And then what we have been working on, it's to begin with, it's an example of a real example of a heat reuse. And in this case, for instance, we are considering that we have 1 megawatt, which is supposed to be 10% of the total load of the data center at 50 Celsius. So of course, that means that we have some sort of liquid cooling. And in this case, I think that we are considering a cold plate or direct to chip. And then we are reusing this heat to heat up a public pool. And again, this is just an example. And this is the simplest possible example that we could think, a close by public pool to a data center. In this case, we figure that it's about 100 meters far, so very, very close, and 330 feet. And we are working in defining all the technical details of this solution, and the cost of the equipment, the cost of the installation, the OPEX, the CAPEX, and then based on this first example, essentially we will expand this example based on different heat reuse and different technology. For instance, if you have a heat pump, if you have some sort of heat storage to balance the heats, all these other options will be, let's say, exemplified, will be shown in this list of examples. And that is essentially what I had to say about our group, our heat reuse group with the OCP. It's very interesting. We have a pretty solid participation, and then what we do regularly, once a month at least, sometimes even twice a month, is that we have presentations from real existing and running heat reuse projects. And of course, as you can imagine, most of them are out of Europe. And even though we work, for instance, in close collaboration with NREL, because they do have a US data center and heat reuse showcase, let's say, in Denver, and then we are working on a couple of projects that are in construction right now, so they will be operational in 2023. With that being said,
Hey, Cosimo, there is a question that came in on the chat. Let me see if I can repeat it. It's on the public pool side, how much power is used by the pumps to transfer all the heat to the pool?
So, first of all, excellent question. We are not done with this example yet. We are still working on all the calculations. We are working on the heat loads. We are working on the pump sizing, the heat loss in these 100 meters. So we don't have all the answers yet. We are working on those, but they will be included in this example for sure. And whether they will be part of the POE or not, we haven't decided yet. Let's say my feedback is that the blue part here does not belong. So if I go back to it really depends where you put this green light here. So the service level agreement, where you put this line, and where you put this line is where the data center responsibility ends and when the heat host responsibility begins. And this is something that we haven't decided yet. Or probably it's something that it doesn't, and actually it's up to us. It's up to, again, as I said, these two different entities decide where they want to put that line.
And a follow-up to that question is the power used by the pumps taken into account to calculate the PUE of the data center?
It's kind of the same answers. We don't know the amount of power yet. Intuitively, it will not be that much. Of course, we are not talking that there's no heat pumps here. They're just just pumps moving water. In the big picture of a data center, my assumption is that they will really not move the needle, but we will definitely have that figure, and then we will decide what to do with that power and where it belongs. But again, it is a decision that will be taken together with all the people in the call. Is not that.
Hey, Madhu, you had a couple of questions. Do you want to just unmute and ask them yourself? It might be easier.
Sure, I'm happy to do that. So when do you see the two sides coming together favorably and nicely, the heat creation side and the heat reuse side? I'm just curious what attributes, societal, regulatory, or inherent, make it a win-win?
So it is an excellent question, and we have to take advantage of the experience that we have out of Europe. So those examples to see how that worked there. And unfortunately, for the most part, what we have is kind of anecdotal. For instance, Green Mountain out of Norway, they're a good company, excellent company actually, and they do fish farming using the heat coming from data centers. Why that happened? Because the CEO of Green Mountain, before being CEO of Green Mountains, was CEO of a fish farming company. So they had all these personal connections. The Lumi project in Finland, for instance, it's an HPC, and they reuse the heat for their local district heating. It's in the middle of Finland, so it's a very cold climate. So they have a lot of months where they can do that. Why is that? Because the data center is really next to the district heating distribution center. There's a wall in between them. That's it. So it became, and it's liquid cooled. So it became kind of natural. And of course, all this is facilitated where you have regulations then force you to establish some sort of heat reuse. At that point, IT companies proactively look for either heat reuse options for where the data center already are, or when they select a location for a new data center, they factor in heat reuse opportunities. This is where we have a challenge in the US, and we have opportunities. I mean, a typical ideal use for a data center heat is either like a university campus, a large hospitals, all these that they constantly need heat, and they would be the first options that you could think of. And all these they have data centers in their premises, bigger or smaller. Now, of course, if you are an hyperscaler and you have 150 megawatt data centers in the middle of nowhere, in the desert in Phoenix, that is it's challenging. But it's a very long answer to a short question, Madhu. But it's the question, in my opinion.
Yeah, thank you very much, Cosimo. We are right on time, but there are another 3 or 4 questions in the chat, Cosimo. So if you could, after you're done speaking, if you could go in the chat and answer those questions, that would be awesome.
Absolutely, but for all the people that have questions, I really encourage to just join our heat reuse group, and they can have all the answers or all the answers that we can put together.
Thank you very much, Cosimo. Appreciate a very interesting talk to kick off our session. With that, we'd like to hand it over to Kaisa Dahlberg. And Kaisa, if you want to present, I think you should be able to share and present.
Thank you very much. Let's see. There you should see my screen, I hope.
Yep, we can see it.
Yeah, super. So happy to be here. My name is Kajsa Dahlberg, and I'm from Alfa Laval, where I work as a hydrogen business development owner for our hydrogen area. And I'm in the central organization based at our headquarters in Sweden. You may know that Alfa Laval are a technology provider within the areas of heat transfer, separation, and fluid handling. And we also divided into 3 different divisions: the energy division, which I'm representing, but also marine and food and water. So I will in this presentation put some perspectives to hydrogen that I hope you will find interesting. And we will mainly keep to the part around production of green hydrogen. But I first want to start off from a little bit broader context. Let's see. I mean, we all know that we urgently need to decarbonize. And this graph here is from the IEA, the International Energy Agency, where we see the projected carbon emissions up until 2050. The top red line is the current trend and how the emissions will increase if we continue the way we do today, considering then the growing economies and the increasing energy demand that comes with that. However, if we live up to the commitments we have promised, although not yet delivered upon, we get to the stated policy scenario. But what we need to do is to find solutions to bend this curve and reach the sustainable development scenario that you find in the bottom. And this is then representing this 1.5 degree Celsius of global temperature increase in alignment with the Paris Agreement. As you understand, this is super complex and a lot of solutions will have to come into play. And the positive angle in this is that given the negotiations that took place at COP26, this climate conference in November last year, the stated policy scenario has actually gone from 2.7 degrees Celsius to a temperature increase of 1.8 degrees. So we are closing in on this 1.5. However, these are commitments that now needs to be turned into actions as well. So as I said, a lot of technologies will have to come into play to make this happen. Energy efficiency will be a main contributor, and it's said to be able to stand for 40% of the carbon dioxide emission reduction until 2040. But we will, of course, also need renewable energy, new fuel types, and carbon capture technology. And to be on track for a net zero 2050, we actually need to halve our emissions until 2030. That's 8 years from now. And the majority of the technologies needed to do this are available today. For example, energy efficiency solutions, battery technology, solar and wind power, and so on. But to reach the targets until 2050, to reach net zero, according to IEA, almost half of the emission reductions will come from technologies that today are in prototype or demonstration phase. For example, green hydrogen, carbon capture, long duration energy storage. All of these will need a lot of investments to become reality. So to accelerate this decarbonization, it actually requires a two-folded approach or two-folded strategy. We need to increase the investments into implementing the technology that are available and commercialized today, and to make these existing industries more sustainable. At the same time, we need to work with a long-term focus to accelerate the development of these new technologies. We need to scale and commercialize them in order to enable then this transition into clean energy and a circular economy. So, of course, what is the Alfa Laval relevance in this? We are offering innovative heat transfer and separation technologies, which are key components in enabling both energy efficiency, clean energy, and the transition into a circular economy. Here, partnerships across borders are fundamental for all of us to accelerate the energy transition. And it is a matter of thinking in new ways, finding new business models in order to succeed with these net zero targets. So at Alfa Laval, we have a strong commitment to be carbon neutral by 2030. And this is, of course, something that also initiates actions in all of these areas here, both upstream and downstream in our value chain. So talking about energy efficiency, and we know that this will be key to reach the Paris Agreement. But at Alfa Laval, we believe that it doesn't get the attention it deserves. Because what is actually more sustainable than the energy never produced in the first place? Energy efficiency is a low-hanging fruit. The technology exists and the potential is there. We just need to make it happen. And this is also what the energy efficiency movement is all about. So this is an initiative started by ABB last year, where Alfa Laval was the first company to join last autumn. And since then, we have worked together to open it up, and it is now available for any stakeholder or organization to join. So it's an open door initiative to increase awareness and accelerate action towards increased global energy efficiency. So I actually encourage all of you to go to this website, which is mentioned here on the slide, and consider to join the movement, because we just want to be more to join us on this quest for a more energy efficient tomorrow. But speaking about energy efficiency and heat transfer, this leads us to the real topic of this presentation, the hydrogen. Because it's not only about making existing industries and processes energy efficient, it's also to make sure that the new technologies that we develop for the future are as energy efficient as possible. So talking about hydrogen, I mean, today, I think it's around 98% or so that is produced as gray hydrogen, which means it's based on natural gas or coal. And this is mainly used for fertilizers or in refinery processes. However, if we look into the future, hydrogen comes with hopes of a decarbonized society, because the hydrogen as such is an emission-free and versatile molecule. And it's possible to use in many different applications or for many different purposes. So clean hydrogen, meaning both green, but also blue hydrogen, where you have carbon capture technology on this conventional gray production, is set to stand for well over 20% of the world's energy demand in a net zero 2050. And in this picture here, you see a very simplified overview of the green hydrogen value chain and what could be our future hydrogen economy. So green hydrogen is produced through electrolysis, where you split water into hydrogen and oxygen using an electrical current. And this, of course, needs to come from renewable energy in order to be green. So the hydrogen can then be used in several different end-use applications. And here we see highlighted as a feedstock for chemical or material production, for example, ammonia and steel, and as fuel for power generation through a fuel cell or gas turbine, or as a fuel for the transportation sector, where you both need to have a refueling station and an infrastructure for that, and of course, a fuel cell within the vehicle. So hydrogen is a solution for many applications to move away from fossil-based energy. However, then it's very important that the hydrogen itself is, of course, based on this renewable power, so it actually is green. Looking then further into heat transfer. Optimized heat transfer is, as we know, needed in more or less any process, in everything from the production of green hydrogen, distribution, storage, and in any end-use application where the hydrogen will be used as a molecule or energy carrier. And as you understand, Alfa Laval is, of course, active in more or less all of these areas, and we work primarily as component supplier to manufacturers of these different technologies, but it could of course also be through EPCs, contractors, and so on. So we basically offer innovative and compact heat transfer technology, for example, in fuel cell systems and Power-to-X applications. But here I will focus a little bit extra on the production of green hydrogen. So looking into the production and the electrolyzer, the two mature electrolyzer technologies today are alkaline and PEM technologies, and they are typically operating at 50 to 80 degrees Celsius. Is that the 120 to 180 degrees Fahrenheit, I think. The process is generating waste heat, which then needs to be cooled off in order to ensure both the efficiency of the electrolyzer and also the lifetime of the equipment. 20 to 40% of the electrolyzer capacity becomes waste heat. And to ensure that this is an energy efficient solution, this waste heat needs to be repurposed. It could be used for industrial processes or district heating if that's applicable. However, the temperature is very low and it's difficult to find a direct offset for it. If we then consider the water instead, for each 10 megawatt of electrolyzer capacity, you need around 50 to 60 cubic meters of clean water per day to be fed into the electrolyzer and actually then splitted by the electricity and turned into hydrogen. So this process water needs to be demineralized and cleaned. It needs to be ultra pure actually in order to ensure the electrolyzer performance. And just looking ahead at 2030, it's today we have announcements of more than 90 gigawatts of electrolyzer capacities globally to be installed by 2030. That also means about half a million cubic meters of water per day, and at the same time 30 gigawatts of waste heat. I think 30 gigawatt could be equal to the capacity needed from like 6,000 wind turbines. So it's a lot of energy and a lot of water. So if we zoom in here, or maybe not zoom in because it's a quite complex picture, but looking at this layout of an electrolyzer plant, you have the heat, or you have the electrolyzer in the middle here in the white area, and it's producing the hydrogen that goes to various end-use applications out to the right. And focusing then on this electrolyzer and the waste heat generated, the electrolyte in the electrolyzer is cooled off by the heat exchangers next to it, and the hydrogen and oxygen produced are also cooled off by one gas cooler each before it's going to further post-treatment. So this heat that we recover in these 4 heat exchangers, it can then either be let out into the surrounding water or air, or it could be used for industrial or district heating needs, or it can be integrated back into the actual process itself, producing the fresh water for the electrolyzer. And as this is a rather low temperature process, 50 to 80 degrees Celsius, it is difficult to find a good offset for this heat. And it's difficult to find a good offset for the heat, and it's not always that you have any industrial purpose for that low temp heat, and it's not always that you have a district heating network close by that needs the heat. So an alternative solution is to utilize it for this thermal desalination solution, producing the water for the electrolyzer, which can very well run on this temperature level. So we will zoom in on that a little bit. This water that is fed into the electrolyzer needs, as I said, to be ultra pure to ensure and maximize the efficiency and lifetime of the equipment. And the most common technology to produce the water for the electrolyzer is through reverse osmosis. This is the technology that you see here to the right. However, for this purpose, to produce water for electrolyzer, the reverse osmosis is not the best alternative, especially not if we are thinking about offshore production, as it needs to be really compact, and the reverse osmosis comes with a large footprint. It also demands quite large amounts of chemicals. It has a higher electricity consumption. You need an additional cooling system, cooling tower or similar solution. And you also need to exchange the membranes quite often, driving a high maintenance cost. And most importantly, the waste heat goes, or the heat in the electrolyzer goes to waste. So an alternative is, of course, then to use this thermal desalination technology, where the water is demineralized to the quality needed with the use of the waste heat. This process is evaporating the water under vacuum pressure, meaning it can operate on this low temperature that we find in the electrolyzer. So we get a solution that combines both the cooling solution and the water generation in one step. You minimize the chemical and electricity consumption significantly. And all in all, the overall process gain around 27% of efficiency in the green hydrogen production, if you're considering the electrolyzer and the water production together. So this solution is especially favorable offshore due to the compact design, and it's actually originally developed for the oil and gas industry, but now has seen a new purpose, so to say. And it's also applicable when fresh water is scarce. So with this, I want to say that we can find new innovative ways of utilizing the waste heat, both in hydrogen production, but also, as I said in the beginning, we need to consider energy efficiency in the development of all new technologies that will take us to a decarbonized future. To just touch upon, or I will finish off here with just an example of a partnership, because I said that partnerships are crucial to take us on this energy transition. We cannot do it alone. And one example of how we partner up with others is in this partnership consortium that we call, or is named Liquid Wind, that's producing or creating solutions for the future methanol production. So in conventional methanol production, that's produced from natural gas, generating a lot of carbon emissions. However, green methanol is today the only market-ready and scalable solution for fueling the shipping industry. And here, Liquid Wind produces hydrogen from wind power, combining it with carbon capture from industries, and then producing so-called e-methanol, primarily to be used as a fuel in the marine sector. So Alfa Laval are a minority investor in this consortium, together with the companies that you see here in the bottom of the slide. And we are also their partner for the heating and cooling solution in the system, making sure that the energy is utilized in the most optimal way throughout the entire process. So with that, I want to thank you, of course, for your attention. And this is now a matter of, when we're talking about hydrogen and green hydrogen solutions, it's now a matter of deploying and scaling and commercializing these technologies to be on track in the race to net zero. And most importantly, we need to make sure that these technologies for that we will utilize in the future are as energy efficient as possible. So thanks a lot. And if we have time for any questions, absolutely.
Yeah, we have time for a couple questions. There's one in the text, Kaisa.
If I can get back to that mode, let's see.
Yeah. You can click on chat, or I could read it to you. It says, in some of your examples of green hydrogen uses, an alternative is to use green energy directly. Example, an electric vehicle versus a hydrogen-powered vehicle. Are there advantages of using green hydrogen versus directly using renewable electricity source? Is there an efficiency ratio to compare green hydrogen versus green energy? And by the way, the next question from me was pretty much the same question.
Okay. I mean, now I see the chat here as well. But I mean, first of all, it is of course highly inefficient to turn electrical energy into hydrogen energy. That's not efficient at all. But it's a way to actually store the energy that we have today, or it's a way to create a molecule that we can utilize for other purposes. Either it can be to store the energy from intermittent renewable energy sources, to store that and save it and utilize it for later purposes when you need electricity on the grid, for example, or when you need to backup generation for your data center, for example. But it's also to turn this renewable energy from solar and wind into a molecule that can be utilized to produce ammonia, methanol, and so on. So it's not at all efficient to do this, but it is necessary to be able to find all of these solutions and that will be needed to move away from fossil-based energy in the future. I don't know if that was the question, but
No, I think you do address it. You're saying in a steady state, the direct conversion may not be the most efficient way, but it is a very good way to store renewable energy for a clean use, like time of use. Is that the essence of what you said?
Yeah, exactly.
And then there's maybe time for one more question. It's how are you planning to officialize the authenticity of this green hydrogen?
Is that related to, I mean, I don't really understand the question, to be honest, but
maybe if I had to speculate on maybe the spirit of the question is, I guess they're asking how green is the hydrogen? I guess that's the question. It's like maybe organic food. Is it really organic? Is the hydrogen really green? That would be my interpretation.
Yeah, and I mean there are a lot of discussions on this, how to secure that the hydrogen is actually green, and I think it will be. I mean, looking ahead to 2030, for example, a lot of the hydrogen will still be gray, but we need to convert it into green and blue, and there will be certification programs and classifications and so on to certify the green hydrogen. And I think also what we will see developing within near time is that you actually produce the hydrogen next to the source. These large scale economy where you actually transport hydrogen from one continent to another, or where you produce it at one site and transport it to another where you utilize it, that's further into the future. And then I think we will have come further with classification as well. But right now, the majority of the hydrogen will be produced next to where it's consumed. And then there will be a different way of securing whether it's green, blue, or gray, or any other color for that matter, because there are a variety of different color denominations on this type of hydrogen.
Got it. Well,
thank you.
Kaiser, that's how much time we have for questions today. Thank you so much for presenting a very interesting presentation. And with that, we will transfer the wheel over to Robert Bunger. Robert, thank you for joining us, and the podium is yours.
Great. Hi, thank you. Is my audio coming through okay?
Yes.
Okay,
Yes.
thanks.
It's coming through great. Thank you.
All right, excellent. All right. All right, let me hide that. I do want to, so hi everybody. Let me get into presentation mode here. There we go. Rob Bunger from Schneider Electric. I'm in the CTO office, and I want to thank OCP and Mark Dancy for the opportunity to share some work that we did through 2020 on looking at what's a good set of metrics to measure, overall sustainability. So I'll kind of take you through a little bit of the journey that we had to and share the list with you. So, why does sustainability matter, right? And I think there's, some obvious reasons we always think of, and this is specifically for data center operators. And, first, especially for hosting companies, customers are now requiring sustainability and sustainability reporting. Governments are starting to regulate this. For a lot of companies, in order to attract investors and to be part of certain funds, you have to have sustainability. And most importantly, it can bring a lot of business value to the companies that are able to implement and improve their overall sustainability. And as a data center industry, we estimate that we use about 2% of global electricity, global energy. And, it's predicted that I think by 2030, that, data center capacity might double. All right. And so we obviously can't double our energy footprint or carbon emissions, et cetera. So it's an important topic. And, if we're able to track and measure our sustainability, right, it enables, operators to grow, broaden their customer base, improve benchmarking against other sites that operators have and even others, and be able to align and collect data across all other parts of the organization that maybe aren't even data centers, and be able to, probably most importantly, shape your strategy to improve your sustainability going forward. And I want to tell a little story at this point. About 2 months ago, in a town over from me, there was a town hall to basically discuss a proposed large data center project for a town. This is new to our area where I live. It was like a 30 megawatt data center, and so the investor and the operator for this co-location data center was there, and the town came in. So even though it wasn't my town, it was town over, I wanted to attend for professional curiosity and also as a little bit of entertainment, town hall entertainment. So so it was very interesting to understand what the people were concerned about with data centers, right? And these people are not used to data centers, right? They don't live in Ashburn, Virginia, right? I'm in Eastern Connecticut. Most of the questions involved from the people were all about sustainability items. How often do the generators run? Are they noisy? What kind of pollution do data centers generate? Is the groundwater going to get contaminated? Are there trucks going to be going in and out of this place constantly? People just don't understand a lot around carbon. The town had actually had set some goals for reducing their carbon over the coming years. And they're like, well, this data center is a huge load for our town. And will this blow away? Will this prevent us from meeting our carbon reduction goals that the town had set for itself? And then there was questions on water use, right? How much water does the data center use? So these are all real questions. 2 months ago, town over for me, which is interesting. Now, 5 miles away, this had me thinking, there is 5 miles away is it was a Groton subbase, right? Of which there are, over a dozen nuclear power plants, right, on submarines that have been operating there for a while. There's no protests, obviously having a number of nuclear power plants, in your neighborhood can be a concern, but these guys were very concerned about this data center. Now, I used to be in the submarine force, and as we got trained on nuclear power, and the theory and operation and all that other stuff, it's crazy rigorous, as you would expect, right? The nuclear power industry is highly regulated, high levels of training, high levels of redundancy, for obvious reasons to ensure that it's as safe as possible. Another reason that they stated all of this is like, look, even if there's an incident and it doesn't cause any damage, it might restrict the Navy's ability to operate where we need to operate, right? The last thing you want is to potentially have to go to a foreign port and they say, hey, no nuclear power plants at this port, or you know, you can't pull in somewhere, or you get kicked out of a base because people don't want. So I feel like the data center industry is in a similar spot where we have to be extremely transparent and upfront with regards to how clean an industry we are. And we've done pretty good overall. And, you know, I think we have to stay ahead of regulations and be able to brag about, you know, hey, we would be a new neighbor, a good neighbor to people. You know, and when we talk about metrics, I always like to bring up PUE, and people say, you know, hey, it's not perfect, but you could always say that, you know, perfect is the enemy of the good. PUE is a good metric, and it has really driven the overall energy efficiency of the facility over the past 10 years. You know, dramatic improvements. They've really been great. So how do we take things, you know, something that has been as successful as that and apply it to other aspects of sustainability? And so that's what we're kind of looking at here. So as we look at, you know, what kind of stuff do we want to measure sustainability? We broke it into 5 categories. First one is energy, which is we do pretty good. Talked about, you know, that data centers currently consume about 1 to 2% of global energy. Of course, there's greenhouse gas emissions, of which there's scope 1, scope 2, and scope 3. And I know there's going to be some other talks about these scopes, which is fantastic. The other one is water. And, you know, I think as Cosimo showed, water is now, you know, 5 years ago, a little talk about it. You know, I'd say in the past 2 to 3 years, a lot of talk about water use. And waste, you know, waste is generated during the construction of a data center, as well as during its operations as equipment comes in and out. And then you have to think about end of life of the facility at some point. And the last one is land and biodiversity. Now, you know, the impact that a data center has on the physical footprint is actually not bad. You think of other industries where this is a huge deal, say mining industry and all that, where land and biodiversity is probably way up on the list of their sustainability concerns, but it still matters. And if you even look through the supply chain for the data center, you can look at, hey, what's the impact of all the stuff I need to run a data center on, you know, on the overall ecosystem. So these are the categories that we broke out. And we also took a look at, you know, how, you know, a lot of companies are at a different stage in their journey to be more sustainable. And so we borrowed or co-opted some of the stages that were used on the journey towards net zero. So this is the, I think, World Business Council journey to net zero. And so we use beginning, advanced, and leading. And so you'll see we broke out some of the metrics by these, you know, depending on if you're just getting started and want to know, well, do I do all of them or some of them? Well, I say, hey, you started, you know, maybe you do some of the energy, some of the greenhouse gas, and some of the water. And I'll show you that in a table towards the end. So I'll walk through the metrics, and as we were choosing them, now there's a ton of metrics out there for all sorts of different industries that measure sustainability, right? So we're not at a loss of what the metrics could be, but we really have to say what really should be, what should they be, and what are the best ones, especially for the data center. And so we took a look and said, hey, are they relevant to data centers? You know, would they, you know, by measuring it, is it something that you can really have an impact on the environment, either directly or indirectly? Can you implement the metric? You know, can you communicate it? Because half of the, you know, important part of measuring is to be able to communicate that through the organization and then actually benchmark and take actions. The other thing we wanted to be able to apply to a lot of geographies, and, you know, it's kind of a standardized metric. So you'll see a lot of these are not new metrics. It's just a chosen list of metrics that we think would do a good job at painting a good picture. So the first category, like I said, is energy, and I bet most of you recognize a lot of these metrics. So total energy consumption, power usage effectiveness, total renewable energy consumption, and then renewable energy factor, REF, and energy reuse factor. So you'll notice in each one of these categories, there will be, we have absolute values, like, total energy consumption, how much does your data center use, as well as ratios, right? And the great thing about ratios is that you're able to then start benchmarking across different size data centers and understand, how they perform against each other. And within each category, I'll highlight one. I'm not going to walk through every single category, but here you can see the check marks of where we recommend, what stage you should potentially use these metrics. And we did it based upon, how available is the information to most operators, type of thing. So energy reuse factor, and highlight this because I knew I was going to follow Alpha Laval on this, but it's the ratio of reused energy over the total energy consumption of the data center. So this would be fantastic if we're able to export some of our energy to to municipalities or swimming pools. You can take credit for it and show that not everything's getting rejected as heat into the atmosphere. The second category, which has the largest number of metrics, is the greenhouse gas emissions category. And you'll see them as a lot of absolute values. So scope 1, scope 2, and scope 3. And you'll see here also that we have location-based as well as market-based. A lot of the large operators are doing a fantastic job purchasing renewable energy and for their data centers. So a lot of them have actually, extremely good scope 2 emissions because of the renewable energy. But it's also good to understand based upon where the data center is in the local grid, because the purchased energy might be, purchased from across the grid, but you're still pulling electrons locally. What is the location-based emissions that happen to be here? So it gives you a richer picture of the data center versus just saying, hey, I'm carbon neutral. It's like, okay, what's that mean? How are you doing that? Carbon intensity, you see here in the middle, is also gives you a ratio so that you're able to kind of compare different size data centers. Another ratio, which is very, very close to intensity, is carbon usage effectiveness. Again, that's one of those bundles of green grid metrics that were now adopted and are part of ISO IEC standards. And then, here we have offsets, which is, sometimes, offsets are a tool that you can use, and it's good to know, how much offsets do you use versus other things to try to get to net zero. And the last one you'll hear, I think, in the last session about hour by hour supply comes. We have this as a leading thing, and super challenging to try to match renewable energy production to your actual load profile. And we don't have the exact units, but you can imagine what's that matching on an hour by hour basis. All right. So scope 3 emissions, just so you know, as an example here, this is indirect emissions that come from the value chain, business travel, waste management. So all the equipment that gets purchased and installed, right, has some kind of, embedded carbon is another term that you'll hear used. So, understanding that. So for data centers that actually have very low scope 2 emissions, scope 3 is the thing that they have to tackle, right, and make sure all the suppliers are able to, one, articulate what the scope 3 or embedded carbon is and all the products that they have over their lifespan, but also what's their plan to reduce that. Water use is pretty straightforward, and and this is water use from usually the cooling system, if evaporative cooling. So cooling towers are your typical example where there's a lot of evaporation happening, and this happens on site. But there's also water use at the power plant, and so these take it into account. So there's water use at the source, Here's water use at the energy source for the power plant, where you're getting power. WUE has a couple of levels, which also take that in, both of those into account. And again, this is a ratio that allows you to compare. And then total water use, which we have as a leading one in the supply chain. So, again, for your purchased products, or how much water was used in the manufacture and delivery of that product or service. And a lot of this, getting this full picture is important for water as a balancing act, right? Because higher efficiency at the data center might reduce water use at the power plant, and you might have different water stressed areas. If you're not in a water stressed area, it might not be important. If you are, then it is. So, having absolute values is one thing, but I think most everybody is, if we're able to be highly efficient and use little to no water, that's where we want to drive to. The other thing that's not stated here, but a little bit embedded in some of these, is reclaimed water. So a lot of data centers use reclaimed water, which is obviously much better than pulling it from the water table. Waste category, again, straightforward. This is how much waste do you generate, how much goes to the landfill, and then you can do ratios. And sorry, there's a typo here where actually the units are tons for the waste diversion rate there at the end. So, there you see a lot of sites starting to go to zero waste to landfill is the goal. So all the cardboard from the server showing up or things like that, and pallets and equipment and all that other stuff should be going to recycling. And then end of life will be another big question here. And the last one I'll talk about, which most people have not heard of, and I had never heard of, we had a work group of a variety of experts in the area to kind of come up, and land and biodiversity is one that came up with. And so this is an emerging one, and this is out of France, this mean species abundance. And it is a metric where you can understand the diversity of life, plants and animals on the physical site. This is a category we think will probably evolve a bit, as metrics become more mature in this area. So this is the full table. I know you can't read it very well, but in this we published this in a paper, White Paper 67. And with the hope of saying, hey, here's a good starting point for the industry. What do you think? And we're lucky to have the opportunity to communicate it to you guys, and hopefully have folks adopt these metrics if they can. So that's all I have. I'll open it up for questions.
Thank you, Robert. There's lots of questions and discussion in the chat. If it's more convenient for you, I could just read them out for you.
Whatever you think is best. Yeah, I can.
Yes.
That'll be good.
Yeah. So combining a couple questions, I think there's questions asked around. There's a lot of features like standby power for, specifically here, QSFP is listed, but it could be any kinds of IT or powered equipment in the data center. What kind of, what is your perspective or view around a lot of those standby or other features that save power?
Oh, yeah. So I'll be slightly all over the place on this answer, but bear with me. So first, I'd like to say, you sometimes hear people say, for the energy category and kind of energy efficiency, sometimes like, hey, if we're 100% renewable energy, does efficiency matter? And of course it does, right? Because the more efficient you are, the less stuff you need to either power or cool or run your IT, right? I think, low power modes, standby modes, and things like that are probably underutilized. And a lot of my feeling is that, the data center industry is a reasonably conservative, historically, industry. So doing things like, hey, I'll run my UPS in eco mode versus, full double conversion, as usually there's hesitations there. And but I think sustainability is going to change everybody's mindset, and we'll slowly work there. A related topic, and I don't know if this is in one of the questions, is we did debate and talk about also utilization of the assets. So you have a data center, what's the IT utilization, what's the facility utilization as a metric? I think it definitely can be debated. Should it be in the metrics or not? I think it's important to understand that. It does wash out in like scope 3, efficiency, as well as kind of scope 3 as compared to what you're producing. But I don't know, I just wanted to mention that.
Okay, thank you. And then summarizing one of my questions and a question from Mark Dancy, which are similar, is, knowing what you know about the future of sustainability in data centers and your close connection with OCP in the past, how could OCP, the data center facilities, help going forward? We really want to get more involved in this space.
Yeah. So, the OCP Ready program might be a kind of an interesting example, right? I think, again, getting ahead of regulation, if there's self-certifications or adoption of metrics or increased transparency with regards to sustainability, maybe there's a program that Open Compute can host that'll allow operators who are really pushing the envelope on being sustainable to get recognized and show where they really stand.
Okay, thank you very much, Robert.
Yeah.
With that, we had planned for a little bit of a break, so we have 4 minutes before our next presentation by Gerald Thibault. I think Gerald is here. So thank you again, Robert, for a really great overview on this space.
Yeah. Thank you very much.
I was very much struck by a comparison between the nuclear industry and the data center industry, and how people and public and regulatory perceptions could be analogous there, and that definitely resonated with me. So thank you for that. We have 3 minutes before we can start our next presentation. It might be a good time for a real brief break if folks want to get a glass of water, grab a coffee. But we do want you all back, all 60 of you. Gerald, are you on? Do you want to get started and get your slides up so we can be ready to go in about 3 minutes?
I was going to say, do you want to give them a 5-minute break or a 3-minute break and stay on track?
3-minute break, but I haven't heard back from Gerald, so I'm just.
Yeah, sorry. I was just getting my glass of water.
Sorry about that. Yeah,
That's
okay.
all right.
We can start in a couple of minutes, Gerald. Would that work?
Yeah, sure. Whenever the green light comes, I'm ready. So that's
all right. Thank you. And then I haven't looked at the list, but is Johanna on? Or Johanna?
I am here, yes.
Okay,
excellent. So you'll be going next.
All right, so I'm sorry, everyone meet back at 10:03, 10:02. Just trying to make sure that we're
10:02.
all right, everyone, 10:02.
So that's
Perfect.
14 minutes, is that right?
No, that's
Oh,
4.
that's a mistake. That's a mistake. Sorry.
I was going to say, I thought we said 3 minutes.
9:52. Sorry.
Yeah,
9:52.
that's my bad. I can't count.
No problem. No problem.
Okay, 9:52. Cool.
I think it is 9:52 on my
Okay.
computer, so I think we're all ready to go, Gerard. Please go ahead.
Okay, as your master of ceremonies, I will do so. Good afternoon, well, sorry, good morning for perhaps most of you. It's just coming up to 6 o'clock in the UK here at the moment, but my name is Gerard Thibault and I am Chief Technical Officer at KO Data, basically a co-location data center company in the UK. And I'd like to talk about transitioning to HVO fuel, or hydro-treated vegetable oil fuel, in our sort of bid to move to more sustainable technologies. If I can just touch on a couple of things that Rob Bunger said, and PUE, absolutely, I think it really is still a very, very useful metric. It's perhaps not the best, as he said. There are things that we can do to tighten up, but I think as an overall driver for efficiency and something that's demonstrable to customers, it's a really useful sort of benchmark. And I think, yeah, ahead of government regulation, we really ought to be pushing the boundaries, each and every one of us, to try and sort of bring this sort of self-certification approach, so that we don't have things foisted upon us. We're leading by example, really. So with that, I will crack on. This is a picture of our data center at our Harlow campus, which is northeast of the centre of London, heading out towards London Stansted Airport, for those who know the geography of the UK. And as you'll see there, we've got 5 very nice looking generators, and all of those are now powered by hydro-treated vegetable oil. We run a sort of standard sort of type facility, so it's an N+1, and I'll talk a bit more about the technical bits as we go through. I will keep the next bits fairly short, but I was asked to just sort of touch on sort of where we've come from and where we're going. We were founded in 2014, and really with the aim of operating high performance data centers. We sort of take it that we're sort of hyperscale inspired. I've got a lot of experience from working with Digital Realty on some big projects over the last 25 years, but trying to make them focused for AI usage and high performance computing. This is one of our flagship customers, NVIDIA, where we've got a very dense sort of installation, and it runs very, very efficiently on an indirect air cool system with evaporation and adiabatic cooling as well. So clearly, as Rob was talking about, there is very much room for more metrics to determine that sort of water usage versus energy saving at point of use, or the location of the data processing, versus what would be used in the generation of the electricity in the first place. So yep, very proud to be part of that. We currently have 3 data centers, and our focus is on developing ultra efficient data centers. You'll see that the top picture there is the one on its way to Stansted Airport. We now have 2 additional sites to the west of London, and our newest one there, Kalon 06, which really fits into our numbering system. I know we don't have 6 at the moment. That is going to be expanded from its current 4 megawatt capacity, again using indirect air and hydro-treated vegetable oil on the generators, to give another 12 megawatts worth of capacity, and hopefully be certified to be OCP ready. We did some work very early on with Mark Dancy around the OCP ready sort of assessment, and I'm proud to say that I think we were one of the first to be on the program, and we've managed to maintain that since our first certification, which I think was back in 2019, Mark, but there we are. Harlow 1, just to give you some sort of basics, actually that's a picture taken slightly earlier in the development, where we've only got 3 generators at the back out of a maximum of 7 in an N+1 format. It's about 61, the campus will be about 61,000 meters squared when it's finished, but each individual building gives us round about 4,500 meters squared of data space. Each building is probably aimed at consuming about 11 MVAs worth of power to deliver up to 8.8 megawatts worth of IT capacity across 4 halls. The PUE is one of the things that we've sort of majored on, and that's really to sort of look at how much energy we use in the first place before we look at other sustainability measures. So we're trying to do the reduce part of the reduce, reuse and recycle sort of loop. We are operating, particularly in our NVIDIA data hall, often on days where we're probably about 11% capacity in that particular data hall at the moment, and we're still operating on some days at 1.18 as a PUE, and up to about 1.27 on some of the warmer days. So we're certainly aiming to meet that sort of predicted PUE of 1.2. So I think that, you know, from a designer's point of view, we've got to start to look at the more efficient methods of cooling to actually reduce the energy that we're going to be using in data centers going forwards, and then how we can then make that even more sustainable by some of the measures that we've heard today, and obviously come on to that. The need for generators, yeah, so really touching back on what Kaiser talked about, is that hydrogen is one of those enablers for storing some of that energy that we can produce by natural means or renewable means. Yes, it may not be the most efficient sort of process in terms of the electrolysis and storage of the hydrogen, but at least it does sort of take us away from using fossil fuel. So that was the real driver for us at KO Data, to move our generators away from standard diesel fossil fuel and move towards this hydro-treated vegetable oil. As I said, when we're full on each individual building, we will have up to 7 of these very nicely painted blue generators or engines. They're MTU, so they are emissions optimized, probably one of the most stringent sort of specifications. They're produced in Germany to be as clean as they can be under fossil fuels. But we spent probably about 12 months or so doing due diligence with Rolls-Royce MTU, just trying to make sure that we weren't going to experience any lack of power or bring any detrimental effects. You know, when you consider that the generators, they really don't get a huge amount of use. So I guess some people may sort of comment that perhaps this change is a bit of tokenism, but I think as we go through the slides, tokenism or not, it's certainly going to save an awful lot of greenhouse gas emissions. So I think it is a very important step, and one that can be done with no real pushback from anybody. You know, there is really no reason why this can't be done. Cost-wise, there's very little in it, and there are no modifications whatsoever. Just looking at the figures there, you know, one of those engines is going to be using sort of 450 to 500 litres an hour. So, sorry, in American terms, I guess that's sort of about 100 gallons, over 100 gallons an hour. If I got my conversion right, probably not. And using fossil fuels, you know, that's going to generate for every 1,000 litres, so every 2-hour run, we're going to be generating 3.6 tons of CO2. I mean, that seems like a huge amount to me, and something that we can do quite a lot about. There are also other issues about burning fossil fuel diesel, and that's the NOx emissions, the sulfur dioxide, and the particulate matter that comes out, which is affecting people's health ultimately. So, you know, it's important to look at these things. Just in blue there, just with a single generator. So we use it's a 1965 kilowatt engine, producing electrically 1.8 megawatts worth of electrical capacity. And because we test our generators for about 2 hours a year, as you can see, that's 43,200 tons of CO2. One generator, one data center campus out of London. Quite a lot. If we look at the wider sort of issue, and this is where I think the idea of tokenism is dispelled in my view, even though there's still lots more to do. London is a big data center area, you know, within Europe certainly, and you know, if you magnify this globally and across the US, there's an awful lot of engines sitting there running maybe an hour a week, 2 hours a month, whatever it is, really not producing a huge amount of useful work either, because sometimes people run them offline. We actually run our data center on the generators for 2 hours. We have a synchronization control where we can run in parallel with the mains as a sort of short-term handshake and swap over without breaking our power to our customers. So we actually run the data center for the 2-hour test every month. So at least it's doing some useful work instead of just burning fuel. But when you look at those figures on the screen there, you know, if you're testing that many generators, and you know, 5.4 million litres of diesel and nearly 20 million tons of CO2, and this is one market. So globally, you know, there's a huge amount there that we can very easily work to get rid of. So last year, even through the sort of lockdown period, we were working hard on our sustainability goals. We working with our both of our fuel suppliers who are on sort of the sort of standard 4-hour emergency backup contracts. Both gave us full commitments that they can provide HVO fuel to us. And we'd worked through our due diligence by that time. So we'd started in 2020 looking at this. And really, they've got no issues at all. It really is what we call a drop-in fuel. In the changeover back in July, effectively, we did empty the tanks and return the diesel fossil fuel back to the fuel supplier. That now, interestingly, we used to get a tax, effectively, holiday on fuel for generators in the UK for data center use. From April this year, we lost that. So actually, agriculture is the only non-taxed fuel user in the UK now. So our prices of fuel for what we used to call red diesel, because they put a dye in it, red diesel was at about 52 pence a litre. This is before all the hikes. HVO was about 74 pence a litre. So, you know, 15–20% uplift in costs. but KO data viewed that that was more important, particularly on the amount of fuel that we actually use on a standard year, to pay that rather than continue with the diesel. We ordered some recently just to top up the tanks, and with the price rises and the additional duty, we're now paying £1.82 per litre as opposed to 74 pence. But you know, still, what price sustainability, I think, is the message. There's no costs involved in actually modifying the equipment. You lose obviously someone returning the diesel because it doesn't have that much value, but it's a one-off change. For those of you who aren't aware, the fuel and the Crown Oil is the company that we actually work with to take the fuel, although both of our suppliers can provide it. The manufacture of HVO is basically from waste food stocks, raw plant oils, cooking oils, you know, real sort of industrial sort of capacity cooking oils. So they're grown. That's obviously where they absorb the CO2 to work as the offset and give us that 90% reduction in CO2 emission. So they've already done a useful job by absorbing the CO2. They do another useful job in actually cooking the food that we're going to be eating. So we're not in the situation where we're growing things just to make fuel. All of those oils are then collected and basically in a sort of cracking and refinement process where hydrogen is added to the oil under high temperatures. Effectively, you get a very, very stable and clear fuel. And that's really where the hydrogen comes in, as Kaiser was saying, in giving us a sort of storage medium for, particularly when we've got overproduction of wind on the grid and network, and it can be used satisfactorily, A, to produce the hydrogen and then to get the hydrogen into the oil. Fully controlled sort of process. So I mean, it's as important to them to produce the good HVO as it would be any other fuel. So again, you know, I think allaying any fears, it really is just a complete swap over, drop in, drop out. It's a one-day job to change your engines over to this fuel. That's what a bottle of HVO looks like. It's fairly non-smelly, totally 100% renewable, biodegradable. If you do spill it, although we've got measures to contain spills and things like that, in theory it's fully biodegradable. So if there are problems, it can effectively seep into the ground and it will sort of break down and not cause any contamination. You know, clearly they're highlighted in green under the clean heading. By eliminating up to 90% of the net CO2 with the growing process, you know, it really is, I think, a very useful contribution. Not the be all and end all, but certainly a very useful contribution and very easy to achieve. It also, the engines now don't smoke like a normal diesel would do when they start up. There's a little bit of very light grey smoke when it starts, but that's just the sort of overfueling, choking to get the unit started. Burns very, very clean, very little smell. We don't get sulfur dioxide out of it because there is no sulfur in the oils. We've done some testing. I think I picked that up in a further slide, but I think the key thing is it doesn't affect reliability as well of our engines. I've worked in some data center companies with very large fleets where we've used what they call biodiesel in the past. Yes?
Sorry, we do need to wrap up in the next 1 or 2 minutes.
Okay. Biodiesel traditionally has got what they call FAMEs in, which are fatty acids. and those used to encourage bug growth. HVO doesn't have that, has a really good 10-year lifespan. And in fact, often our company has said that it really doesn't even need fuel polishing either. That's important, I think. Cost effective, as I said, there's no real sort of cost to transition. The fuel is more expensive, but again, that may well come down the more people use it. In the Nordics, people actually use it for their cars. You can get it on the forecourt for diesel cars, which obviously is bringing prices down. We actually did some real testing to help with our permitting on site, and we found that we have, as part of getting the benefit of the 90% reduction in greenhouse gas, we've also got a 13% reduction in particulate matter, so better for sort of cleaner air, but also a 6% reduction in NOx emissions as well. So, and as I said, the hydrogen going into the oil actually increases the cetane value. And as you can see from the table there, and I'm sure these are being presented to people afterwards, we actually get more power out of the engine on the unit. So we don't suffer loss of power, we actually get a slight boost, peaking at around the sort of 75% load, but interesting that you actually get more bang for your buck. There is a white paper that you can download on it with a bit more detail, and also there's a link there to look at our announcement, and that's me. Thank you very much.
Thank you very much, Gerard. Maybe one brief question from the chat would be,
Yeah,
can,
sure.
can diesel generators be used with the HVO fuel with minimal or no changes?
Absolutely. We made no changes whatsoever to our fleet. We just drained almost down to zero, in probably about 200 litres left in the bottom of the tank, and then added the HVO fuel. No changes whatsoever to the engine controls or whatever. We have made an agreement with Rolls-Royce, who own MTU, that will submit a set of injectors after 500 hours of running. But as we only run 24 hours a year, that's going to be quite a few years down the line. So they've basically got no concerns, and literally is a complete drop in fuel, no changes whatsoever. So I would encourage everybody to obviously just check with your engine manufacturer, but if you can do it, I would certainly recommend that you look into it and make that change.
Okay. Well, Gerard, thank you very much for a very interesting and relevant presentation.
Okay, thank you very much.
Gerard, there are a few questions in the chat, so if you wouldn't mind peeking in the chat and maybe addressing some of them directly, I think those asking the questions would really appreciate it.
Yeah, no, absolutely. And I'll with that, I guess I'll stop sharing and let the proceedings continue.
Thank you. Our next presenter is Johanna. Johanna, do you want to present and get going?
Yes, please. I'll share now, if hopefully you can see it.
We can, yeah, please go.
Get rid of these controls somewhere, and that's even better. So everyone can see it and can hear me then. Okay, great. Good morning to you. I'm also in UK, so it's evening here, but all the same. So I'm here to talk more about how we can get to maybe zero carbon future. So I am from One Click LCA. We are software developer and developing construction manufacturing lifecycle assessment software. And we have different software solutions depending what you do in the construction industry. If you are a builder or manufacturer, or doing other GHG accounting reporting for any other purpose. And we do also work across the construction sector around the world. We have clients about 145 countries or so or users, let's put it that way. From manufacturers to investors and also some data center providers and contractors. So there is a need to reduce carbon emissions. That's my point number one. Then we talk a little bit about the built environment, who needs to do what to actually reduce them, and then how we can possibly help you to get you started or further into the world. So, I mean, I'm sure everyone is aware that the climate is changing and is causing disruption, and also quite a lot of different weather phenomena, which shouldn't probably be happening. And also it's changing quicker than anyone thought that it could change. So there is obviously other different kind of results on this change, and obviously one would be the seaside, like sea levels rising and climate getting somewhere getting drier and somewhere getting a lot more wet than it has been in previous years. And also us building new building stock, it's not helping on the climate change. Someone has calculated we are actually building equal of New York City every month, which is a lot of land to be covered by concrete, for example. And it's been thought to double in 40 years if we keep on going the rate we are and how we are building as well. So from just building more buildings, the carbon impact will accelerate the climate change by 6 years. So there's a carbon emissions from different types of sources. Obviously, the actual building materials like metals and cement or concrete, and then there is the energy use itself, and obviously repairs and all that will add up. So obviously resource depletion is also something that can be seen and will be coming soon enough. And also think about the climate impact. Designers, builders, and manufacturer has a lot more impact, or if you are one of those, more impact at your work than personal level. I mean, we can all recycle and so on, but your climate impact at work is definitely 1,000 times bigger than you can do on your personal level. And your customers and your competitors are already taking this into account. So they have started to calculate their carbon emissions and also reduce them. So there is a real need for obviously everyone to get on board. Obviously there is some hoops to be going forward. There is obviously lack of time that we all have. There's a cost associated reduction. Need to think about things a little bit different ways. Getting your head around a lot of things, how things work. However, if you don't do anything and want to stay competitive, act to not to act now is probably not wise move. I think everyone should try to do their best and stay competitive, and so your supply chains and such like can actually keep happy. So who needs to do what? There is obviously a lot of things you can do to reduce carbon. The clients can write nice briefs. You just use less materials, you circulate, refurbish, designing out carbon. There's also a lot of innovative products like different ways of producing energy coming on market. They all obviously help. But there needs to be carbon cuts. And the previous presenter, or the one before, stated about the GHG emissions. So the scope 3 emissions for contractors, developers and consultants are a lot higher than the scope 1 and 2. So between 75 to 99%. So it's pretty much all scope 3 and embodied carbon related. So it's clearly the right place to reduce that. There is a lot of LCA regulations already being put in place in different countries. In UK, there's city level. Some countries like Finland and Sweden and such like has a government regulations, and France. So as staying good terms with these governments to start with, it's also a good idea to start considering how you can reduce your carbon impact. Also, the life cycle assessments are required for in different certifications like LEED and Living Building Challenge and BREEAM, and more, and they get more credits. And also there is a real call for action from a lot of different associations like World Green Building Council and so on, to cut embodied carbon by 40%. So in here, embodied carbon is meant by anything from manufacturing, carbon emissions from manufacturing, transporting, replacing and disposing the materials on that matter. So as you can see, the construction has something to do. Obviously, it's good to look operational carbon, which I know that the data centers are looking, and how much the power ratios and such like work. However, if you want to get net zero, you're reducing operational carbon itself. It's not really going to help. Operational carbon is also quite a few places reducing as we speak, because there's more renewables and less oil and such being burned. Any kind of fossil fuels have been phased out. However, embodied carbon from material extraction and such like will stay unless you make conscious effort to actually reduce it. And the net zero should not look like this. It should look like actual zero. And who would have the biggest potential to do something about it? And it is investors and developers. So early stages, it is basically the biggest opportunity to do any cuts. So your specifications, your demands as an investor would be the place to start. Obviously, designers can then do their best and further reduce them or do something about it. Also, people who are specifying items can also still find better manufacturers, replace some items, maybe reduce some material consumption. However, obviously, if it's already been tendered, it's already been designed and gone through planning, the contractors will have limited things to do. They can't change the whole construction, for example, from steel to some nice CLT cladding. It's way too late. It should have already been specified and demanded from the start. And that's the reality there. And how we can help you, obviously, like I said, we do different tools. So anyone can get going, start calculating what they're doing now, what kind of improvements they can make on their carbon footprint, either embodied carbon, whole life carbon, or anything between that really. So One Click LCA is a web application. It's cloud-based, run in a data center for sure. We have tried to make it easy so everyone could just log in and try and see what there is. If you are anywhere in the design process, you can just check things that what would be better than others. You don't definitely not need to have a PhD for doing so. And you can also use the tool in every project phase, and also by sharing and connecting data. So you obviously, it doesn't need to be one person in design team using the tool. You could construction, like contractors and anyone involved in construction, or even we have also tools from the manufacturing side. So any kind of stages of your designs or your product designs as well, you can make sure that you can calculate the embodied carbon or whole life carbon in there and see what reductions you could make and make better choices for your building or your refurbishments even. So obviously early decision have a highest impact as shown, so the developers and such like have a largest impact. They also obviously are the lowest cost when you do them early. So things thought about well in early stages has a highest impact. We obviously, our software integrates with a lot of different design tools, so you can use the information all the way along once you have a drawing, but you can also do early stage optioneering, quite detailed, without not knowing much, just to decide which way you want to go before you start to doing actual drawings. And then you can obviously make sure you reduce it all the way. So this Carbon Designer 3D tool, for example, you can compare options before you have any drawings available. You just have ideas, so you can play around in different shapes, sizes, different constructions, and see how you could already get on the way of reduction of embodied carbon in your buildings. And you can obviously get loads of presentations as well, so you can identify your hotspots of which items there in your building are the biggest culprits, and see what you could do with them, if anything. You can also find opportunities for improvement, so there might be some things that you haven't thought that might be helpful. And also you can obviously use it for reporting and show maybe also your clients and your supply chain how well you can do, and also use it for your reporting in the end of the calculations. You can also do portfolio, so you can look through all your buildings and see how they perform next to each other. We have some clients like Segra who builds industrial units. They have done this for a few years now, and they have every year more reduction targets for their design teams across the world. So they can see which part of the world it's the best buildings, and they can do lessons learned and push the design teams to build better and more efficiently. So like I said, you can integrate the tool, our application web tool with different design tools, so you don't need to do anything manually. Obviously that's also available, so you can bring data in from your design team, your architects, engineers, energy models, and kind of bin management tools and such like. And also the manufacturers will bring their data in their product declarations and such like into the mix, so you have a fresh information from to do your calculations too. So like I said, we as in one click also take all the published EPDs, environment product declarations, into our software. So wherever manufacturer does their calculation and publishes it, you will find it. We also have other carbon data sets from around the world. So not necessarily just manufacturer, but generic data to fill the gaps of lack of EPDs. Hopefully we have more in years to come, so we can do it quite quickly. And then you also have constructions and such like to work on. So we are currently running about over 130,000 data sets. So basically you would need to bring the quantities of materials, and the carbon data is there to be used. So you don't need to find anything else than except quantity data yourself. And then you can use the tool, not just obviously carbon improvements, but also doing certification calculations or comply with regulations, different countries. So we have a compliance tool for every country that there is a regulation currently, and any other regulations coming up, like I think Vancouver just voted yesterday, or city level embodied carbon. So as soon as we are aware how they want to calculate it, we'll add that to the mix of regulation. But we do support typically all of them there. So in just a summary, that we have tools for all your needs, and then you can also exchange data if you're a manufacturer, contractor, or you are the actual other end owner or so. So you have your product carbon and LCA tools, then you have construction tools like net zero tools. You can do building circularities, life cycle costing and such like, and then you can link that to your GHG accounting, so carbon strategy tools or also. So there is something for everyone. So I mean, decarbonization is necessary to at least slow down the climate change. I mean, it probably does still change. So we have a lot of training as well available. We have summer school in European time zone as well as North American time zone over the summer. We do a lot of research and policy pieces as well, so you can read more about it if it sounds scary at the moment. And then we also have loads of in-house experts who can help you on the way. We also have a couple of webinars to those who are in more on the US time zone. We have a few on the US Central Time coming up. One is AIA approved as well. So if you are a designer, you can get some credits there. And other one is also going through the SC 2050 commitment. So have a look. And that's about me done. If you had any questions, I'm happy to answer any.
Sure. Johanna, one question.
Yes.
What are the primary drivers for customers or clients to use the tool, and what are the primary barriers around? Maybe it's usually inputs to the tool, or the effort in training, or awareness and motivation. So just curious from your experience.
So the first part was why? Why would anyone do this?
No, I think you've explained why, and I think
okay.
this whole tech talk is you're preaching to the choir, or we all are interested in it. But I'm just curious, what actually gets people to start doing it, working on it, and what might be barriers?
I mean, quite often, if you think of developers' point of view, that they have pledged that they're going to be net zero for, I don't know, 2030. So then obviously how to get there, they need to see where they are at the moment so they can start calculating the emissions now, and especially what they build at the moment, and maybe do some benchmarking for their older developments, see what they do and maybe also include in use energy in there to see what they can do. That's from the developer's point of view, as well as architects and designers seem to also obviously want to be net zero, because that's, especially in UK, because there's overarching legislation that everyone has to be net zero by 2050, entire country. So that's quite often the case. Some might be obviously wanting to get a high certification rating. So I mean, maybe they want LEED Platinum and they have to do every credit going. So that's also, and then they can see, so maybe they have a LEED that they will, all their buildings will be certain levels. So that's typically where it all starts. And obviously reporting purposes on their social and ESG reporting, it's something that they can. Scope 3 emissions are a little bit difficult to report if you don't do any embodied carbon calculations.
Okay. And is there anything different about the data center industry related to the use of the LCA tool versus building or other industries?
No, I wouldn't say so. I mean, obviously the energy use is completely different scale, I think, but but not in that sense. It's the same, used same way.
Okay. Well, thank you very much for your presentation, and we really appreciate you making the time to come and present to this forum.
That's fine.
Thank you. Our next presenter is David. David, are you on? And would you like to start sharing your screen and get going?
Yes, sure. You see me?
We do see you, yeah, and hear you.
Great. Just preparing. Okay. So just sharing the screen.
David, while you're doing that, Johanna, there are some questions in the chat. So if you could take a look while you were speaking. I know we ran out of time, but it'd be great if you could address them there.
I'll have a look.
Thank you.
I'm trying to share the screen, but then don't see the option.
There should be an option because Johanna is no longer sharing. So at the bottom of your desktop, do you see a bunch of buttons?
Yes.
All right,
I
does
see,
one of
but
them say share screen? It's 1, 2, 3, 4, 5, 6th one for me.
Do you see the MOR more? There may be more options. Do you see those?
yes, but there is, and we will go through it
This meeting is being recorded.
in my presentation. Please, next slide. So this presentation is divided for 3 parts. What is scope of the emissions in data center, how it can be reduced, and what is can be done in OCP ready data centers. Please, next slide. And now let's talk about emissions. What is that in that center particularly? Next slide, please. So there is one direct emissions, which is generated on site of that center. And 2 rest, scope 2 and scope 3 is indirect, which is connected with energy supply and all the rest. Next slide. So if we look on the on-site, this is generated by gensets only when they are working, and this is their fuel consumption. About the chillers, there is a leakage, and this leakage filling and update, this is the scope 1 from the point of view of the refrigerants. And another which can be is the local gas boiler which heat up the data center building, or vehicles which is used on data center purpose. It's different delivery things and etc. This is small scope 1, which is connected with data center operation. Next one, please. Another one is most the conversation about that is scope 2, energy supply, and it's connected with the all input electricity, which can be from renewable power or not renewable, nuclear, and etc. But also there can be a chilled water, which we deliver it for the cooling the data center, or fuel cells. This is all energy supply, and this is all is scope 2. Next slide, please. But just to evaluating what's the impact from these sources, I just show the CO2 emissions by electric energy. It's mean coal, natural gas, and another part from the right side is for heating. And if you look, the electric part is have more impact than the heating, because the efficiency of the fossil fuel generation is just 30–50%. And for that reason, they produce 2 times more heat rejection than the electric energy. And for that reason, the CO2 emissions for electric energy generation is higher. But if you look for the wind or solar, they provide only electric energy, but there is no heat rejection. And for that reason, there is nothing. Please, next slide. So next one is scope 3. This is all the rest carbon impact, which is connected with upstream, downstream. And if we use, let's say, renewable power, in that case of data center carbon emissions, this should be from 80 to 95%. And this is the main area where we can reduce our impact. Next slide, please. So if we look for the upstream, there is capital goods, which included in itself data center building itself, servers, racks, UPSs, cooling system, digital gensets. That's all is capital goods. Another thing is purchased goods and service, whereas in software, spare parts for the servers, fans as spare parts for the cooling units, and etc. Another thing is fuel and energy related CO2 emissions. So the fuel transportation, fuel itself, and energy transportation, the energy cost for the transforming and etc. This is the scope 3 energy related emissions. Next slide, please. Also, there is a waste generation. It's meant that all packing which come with the servers, with the racks, with the equipment, this is the scope 3 which connected with this waste generation. Also, transportation of all goods which deliver for the data center side, it's also scope 3. And employee commuting is also included in scope 3. Next slide, please. Now, a little bit about downstream. So the servers which have end of life, this is the downstream scope emission. Also the batteries from the UPSs or the air conditioners and refrigerants. This is all downstream scope 3 emissions. Also, the transportation of that goods from the data center side to the other places is also downstream. Next slide, please. And now let's evaluate how we can improve, how we can reduce that impact in data center. Next slide. For example, if we have refrigerants with high global warming potential, we can change them or use on new sites natural-based refrigerants or refrigerants which have GWP 1 or close to 1. And this is even a demand in US and Europe from January 2022 to use such refrigerants. And when we will have a leakage, we will fill it up again, but much less impact on the environment. Another thing is liquidity transfer, which give us opportunity to not use any mechanical cooling and avoid any using natural refrigerants or any refrigerants just by heat transfer with high temperatures, which don't need mechanical cooling again. Next slide, please. If we talk about scope 2, the most of the data center switching to the renewable energy. But as I said, this is just 5% of the impact. Also, there is opportunity to use seawater for cooling, which also make less impact from the point of view of carbon footprint. And some data centers use that. Next slide, please. And now about scope 3. This is the huge potential to have a work on in that direction. But if we look for the OCP approach, there is a real case when you can use second life servers, because OCP approach give you that opportunity. Not only give the second life for the existing servers, but also use them for the other applications which don't need high performance, and you can use 3 or 5 years old servers for the other purposes like schools and other applications where you don't need high performance. Also, from point of view of the packaging, if you buy OCP prefabricated racks, they have much less transportation volume. They don't have unnecessary packaging for each server and for rack. You reduce this environmental impact from the packaging point of view. This is just 2 examples. Please, next slide. And now let's have a look what can be done in OCP-ready data centers, which are already created for the OCP racks. Next slide, please. But let's evaluate how it's go energy in the data center where there is closed loop air circulation. So you get from the grid 1.3 megawatt to provide 1 megawatt for the IT load and 0.3 megawatt for the cooling. And all that energy is transferred to the heat rejection. There is no way to hide the energy. And that all transferred to the environment, to the ambient air. And the cost of the electricity for 1.3 megawatt is 100 euros per hour. Among them is for cooling 23 euros per hour. These figures is just to understanding what is the cost. Please, next slide. And if you want to heat up the same amount of the heat, 1.3 megawatt hours, you should burn 200 cubic meter of natural gas. By burning this gas, you will have half ton of CO2 emissions each hour. And if we go to the pricing, we will get 1,000 euro, 1,500 euro by each 1,000 meter cubic of gas. This is give us 200, 300 euros per hour. And if we go to the Sweden, there is a emission tax for CO2, which is 116 euros per ton, and it gives us approximately 60 euros per hour if it will be accepted also in other countries. This is looking forward cost. Next slide, please. But if we choose circular economy, in that case, we will get the same 1.3 megawatt hour from the power grid. We provide 1 megawatt for the servers, but we can use heat pump, which provide and cooling for the servers and heating for the useful applications. In that case, we will get 1.3 megawatt hours of heat, and we not need to burn natural gas, and we save that amount on savings on the gas and the savings on CO2 emissions. This is just example how it can be not only decarbonized, but also financial more attractive, and for heat provider and for data center. Please, next one. But as you know, there is many hyperscalers which don't use closed loop. They just use outdoor fresh air and cool down by these servers. They don't use chillers and etc. And this just exhaust air go to the environment, and it is just 1 megawatt hour. Please, next one. But even for that case, there is an optional solution where you can use ducts for distribution for heat up the greenhouses. And this is another approach which also save the natural gas consumption on the greenhouse side, and also save the emissions by burning that natural gas. And this approach actually is not used somewhere. This is just theoretical idea. How can be used exhaust air without any heat exchangers, without any pumps, but by heating up the big spaces by this air duct distribution. Please, next one. And this is a short explanation how can things be done with using the same equipment and evaluation of the hotspots in data center. Thanks for your attention, and I will be happy to answer on the questions.
Archana, any questions? I can stop presenting also in chat.
There's one question here, and I don't know whether it's directed towards you or not. David, it says, would a modular transport container be a good way to utilize Second Life kit for education that could sit next to the existing building? So I don't know if this is for you.
I can say that there is an offer on marketplace on OCP where you can find modular data center, for example, with immersion cooling, and actually you can use that to explain how things can be done. So buy just one tank from Submer or Esperitas with OCP Second Life servers from IT Renew, and that will be a great example how things can be done. And actually it can be used for the heating the same school or the other educational building.
That's the only one that I see right now in terms of questions. If anyone else has a question for David, please feel free to unmute and ask.
Yes, I see there is a question about greenhouse. Yes, actually there is opportunity to integrate the greenhouse and the data center. And if we go to the Netherlands, there is a company which name is Block Heating, and they do that, but they use dedicated on-chip heat transfer, and it's have good potential.
I think that's maybe all the time we have. David, thank you very much again for contributing to the presentation and providing interesting discussion. Archana, do we just plow through the last presentation, or would you suggest a brief break? What do you think?
I would suggest we plow through. Maud is, I think, here, and we can just get him there. And then if folks want to stay afterwards and have an interactive discussion, we can, and leave it up to them. How's that?
Sounds great. Hey, Maud, thanks for joining. If you want to try presenting, please go ahead.
Okay, thank you, Madhu. Hopefully my camera works as well. It says it does, but let me know. Okay. Does it?
We can't see you yet.
Yeah, I think I have issue with the permissions because it's the recording, I think, that is blocking for some reason. Okay, Madhu, I'm definitely blocked on the screen sharing also.
Madhu, do you happen to have Maud's presentation?
Yeah, sorry, I was on mute. I do have the presentation and I can present.
Okay. Can you see my camera? Because it's on, but I just don't see it.
No, we can't see you, Maud.
This is really interesting. Okay, let me try to. Okay, I'm not sure what's going on because that was working yesterday on Zoom. All right, well, maybe I might just close through. I know you have a tight timeline, so as soon as we have the slides.
Okay. Let me know when you folks see the slide and we can get going.
We can see them.
Perfect. Okay, thank you. Sorry for the technical issues on all the different platforms. Thank you for hosting me today. As a representative of Google, my name is Motexi. I'm head of energy development for data centers, specifically focusing on our clean energy programs and carbon reductions program for the data centers. So today we wanted to give you an overview of our 24/7 carbon-free energy program, which is our main objective as part of our Scope 2 greenhouse gas emissions. Next slide, please. Just a very quick background. I'm sure most of you might be familiar already, but one of the key reasons why we've been focusing early on electricity footprint is really due to the nature of our portfolio. So today we have 21 locations, data centers that we own and operate directly across 4 continents. And so altogether that represents a substantial energy footprint that we have direct control of. And so that's why we really wanted to double click on this carbon footprint and try to see how we could reduce it as quickly as possible. Next slide, please. So this is just a translation of the map that you saw before. In general, you know, the data center industry has been growing pretty fast, as most of you know. And so in 2020, we were close to 15 terawatt hours in global electricity consumptions for that year. So this is, as our load keeps growing and we keep expanding to new regions, one of the key conditions and drive for us is to make sure that this new electricity is going to be decarbonized as quickly as possible. Next slide, please. A bit of history about Google's sustainability and energy journey. We really started with our first sustainability program in 2007 with carbon neutrality. Back then, greenhouse gas emissions, the protocol were pretty new and emergent. A few people were already looking at reducing their carbon footprints, and carbon credits and offsets were an emerging markets. And so we started our own carbon neutrality program, which is based on high quality carbon offsets that we purchase to cover our operational emissions. What that means is generally it covers our net emissions for Scope 1, Scope 2, and a small portion of Scope 3. As we implemented this carbon neutrality program, we also realized pretty quickly, as I mentioned, that our Scope 2 was one of the substantial pieces just due to the consumption of the electricity that we had for the data centers. And so that's why early in 2010, 2011, the team started putting together a clean energy procurement program to make sure that we could purchase our own clean energy in the markets where we could offset the footprint from this electricity consumption. And so we started with this program that we call 100% renewable energy, which is really about trying to procure the right amount of clean energy on an annual basis that would cover the carbon footprint of the electricity consumption of the global fleet that you saw just before. We achieved this 100% match in 2017, and we've been maintaining that 100% match since then. As the load keeps growing, we need to keep finding new projects to do that. But as we've done that since 2017, we also realized that this annual global matching was a good first step, but it was not really going to drive the direct decarbonization of the actual electricity consumption on a more granular basis. And so that's why we created the 24/7 carbon-free energy program, which I'll talk a little bit more about. But that's really our next goal, I would say, in our sustainability journey. And by 2030, we're hoping to achieve that goal for all of our data centers. Next slide, please. I think we can skip this one. I already mentioned it. This is the 100% renewable energy match. Thank you. That we've been able to maintain since 2017. And here is an illustration of why we want to go further now that we achieved this first step. When you take our 100% renewable energy portfolio and you apply it to a specific data center or specific grid where we have consumption, this is an example of the Iowa region here. So in Iowa, we have a large wind portfolio. So you can see in green the productions of those wind contracts that we have. It's pretty spiky because wind is intermittent depending on the wind speed. And so you can see here that we have some hours where we have a lot of generation, so with those green spikes, while we have some other hours where actually we have some gaps. The wind speed is pretty low, and our data centers are still consuming because we need to run the internet 24/7. And so it's really when we started laying out this map between production and consumption on a more granular basis, both from a location perspective, but also from an hourly perspective, that we realized that we had to reset a little bit how we were approaching clean energy and clean energy procurement to make sure that we could claim the decarbonization and the impact that we're trying to drive on the grids and the regions where we operate directly. Next slide, please. And so really our goal is to take the graph that you had before with the spikes that you saw in green and the gaps in gray, and to ensure that by 2030, we're going to have just a flat block of green that is matching our consumption in all the places where we are operating data centers. So that's really what we've been driving for since we announced the program in 2020, and working on this next decade to make sure we can decarbonize all of our operations. Next slide. Maybe just pausing here, and 24/7 carbon-free energy as a program for Google is really a goal that is focused on our own operations and decarbonizing our own operations. But really, the reason why we are doing that is because we strongly believe that electricity is at the core of broader decarbonization of our global greenhouse gas emissions. And that is, oh, here is my camera, great. And that's why we've been really pushing hard on what is the theory of change to drive decarbonization of our grids, decarbonization of electricity. Here is an interesting graph that is coming from the IEA Net Zero report that I encourage people to read if you're interested. But basically, electricity has this massive role of emissions today, but also a massive role in helping us transition to carbon-free energy through electrification of buildings, electrifications of transportations. And so that's why by driving this theory of change of how do we create 24/7 carbon-free energy, carbon-free electricity, we think that is going to be really a stepping stone to accelerate much broader decarbonization efforts. Next slide. Great. So this view is the same global fleet that I mentioned earlier, and looking at how we are performing today, or at least that was in 2020. We haven't published our 2021 numbers quite yet. But how are those data centers performing when you look at our clean energy portfolio or consumption, and you look at it on this 24/7 granular basis? So the first good news is when we started in 2020, we could actually leverage all the clean energy portfolio that we had procured over the past decade as part of our former 100% renewable energy program to really come towards 24/7. So it was not about starting from scratch. And so that's why in 2020, on average, our global fleet was 67% carbon-free energy when we're doing this matching on an hourly basis. However, what is interesting is while we're already at 67% on a global and annual basis, you see that the colors and the different circles are actually quite different. And so we have a high variance between our data centers, with some data centers that are very high CFE, above 90% already, because the grids are pretty clean, or because we have a lot of clean energy procurement already in those markets that were more favorable. And on the contrary, you can see some of the circles that are pretty gray. And those are reflecting just the more difficult regions for us to decarbonize, either because the market conditions do not exist for a buyer such as Google or other consumers to have access to clean energy options, or also because there are physical resource constraints on just the ability of building those clean energy alternatives that have not been really developed or accelerated quite yet. So this first view is a nice way for us to also understand what are going to be the pain points and the gaps, and how we're going to need to focus the roadmap moving forward to really solve those pain points. Next slide, please. So as we are developing the roadmap and trying to execute our first projects and get this percentage score up over the next few years, we also defined a couple of principles to make sure that those were going to guide our decisions and the efforts also, and where to invest our efforts. So the first ones are pretty straightforward. This is the nature of 24/7 carbon-free energy. First of all, moving from a more traditional annual procurement perspective to an hourly matching. And so that requires us to be much more granular in terms of data and analytics and systems that we're looking at. Second of all is also going from a global to a more local perspective. And so we're looking at what is the consumption, what is our footprint in the grid, in the community where we're actually operating. And then the third one is kind of by nature of the problem, we had to really extend our definitions from 100% renewable energy to a carbon-free energy language. And the reason for that is because we know that renewable energy is going to have a very large role in decarbonizing electricity, but we also know that wind and solar are not going to be available all the time and in all the places where we need them. And so that's why we have a more technology inclusive approach and looking in general at any types of carbon-free energy technology that will be able to be added to our portfolio. We keep our principles of additionality. Some of you might be familiar with that, but basically it's how do we make sure that the investment, the projects that we are developing are additional to the grid and would not have existed without Google. I would say today with the development of renewable energy, this is a more nuanced guidelines, but this is really what we keep in mind is how can we make a difference that otherwise would not have happened without our efforts and investments. And then finally, the last principles is what we call the grid is the ultimate goal, and keeping in mind that we're creating this program to drive our operations decarbonization, but this is really also about creating a momentum and creating the discussions and the forums to drive changes and decarbonizations beyond our own operations. And how can we influence the grids and how can we help other stakeholders decarbonizing faster, but by developing those innovations and those new tools that we need for our own goals and principles. Next slide, please. So how we are going to define and execute on the roadmap, we really have 3 work streams. The first one is what we call purchasing. We've been buying clean energy through power purchase agreement and other transactions tools for more than 10 years, and we're going to continue to do the same. We're just going to need to innovate and change a little bit our approach on how to source the projects. How do we make sure that we find the right projects for the right time and location? And how are we doing that in a scalable and efficient way? The second one is around technologies. I already mentioned that we have to go beyond wind and solar as clean energy resources. And so that's definitely one aspect of the program. Another program around technologies is everything around this concept of more granular and real-time operations. And how do we make sure we are equipped to do that? And then what are the opportunities as a consumer to also act and shape our own capabilities to be able to match the supply and not just look for the supply, but also when the supply is present, can we do better? Can we try to adapt ourselves to the conditions? And then finally, policy. I know there were a few discussions already, but one of the strong theory of change for us is the greener the grids are going to be where we operate, the better it's going to be for us, but also for everybody. And so that's why by creating the 24/7 carbon-free energy program, we also create this company incentive to really engage in working with policymakers and stakeholders in pushing for grid decarbonizations, really at the national level, so that we can really accelerate those efforts and see a return on our own operations and our own greenhouse gas emissions reductions. Next slide, please. Okay, this one is a quick example on how we've been thinking about how can we buy 24/7 carbon-free energy in a way that doesn't require a trading desk and an operations team of 20 people to manage all the many contracts and all the many resources that we need. And so for that, we've been working with partners such as here AES for a data center in Virginia. They're a large energy supplier and energy retailer, and we've been working with them so they could create a portfolio of carbon-free energy resources for us that they're going to manage, and they're going to package and deliver directly to us, to our data center as an electricity contract. And so you can see here the portfolio that they created, which is made of solar and wind and hydro, but also adding a little bit of batteries that you can see in red, for instance, to help us really get this 24/7 carbon-free energy shape. And so this is one way on how we're looking at simplifying transactions around clean energy. Some of you might be working on buying power purchase agreement, and those are very complicated. And this is a key barrier that we see in general for any consumers to have access to clean energy, is how do we reduce complexity of contracting for people to have more access to clean energy. And so I'm glad we've been able to develop this model with AES, our partners in Virginia. And since then, we've also replicated the same model for our operations in Germany, actually. So we can see how this model is starting getting more standardized, even across countries and across continents. Next slide, please. Shifting to technologies, as I mentioned earlier, we have really a focus on hardware technologies on one side and software on the other side. This project is our first pilot of new hardware technologies to help us generate clean energy. So for 24/7, we really have two types of issues, or I would say challenges, that we're trying to solve with those technologies. The first one is in the regions where we're going to have a lot of low-cost wind and solar resources, how do we maximize them? To maximize them, we're going to need to find ways to store this electricity on a short-term basis, but also on a longer-term basis. So that's why we're looking at storage solutions and technologies on these specific work streams. But also on the other side, we know that we're going to have places where wind and solar are naturally going to be limited. And so in this case, how do we just generate the clean electrons in the first place? And that's why geothermal was an interesting tool for us. And Fervo, who is an advanced geothermal early stage companies, are developing this new technology that would potentially really unlock access and potential of geothermal in many countries and many regions. And so we started our first pilot with them last year for a data center in Nevada. Next slide, please. This one is an example of a software technology development side. We have been working with many other people in the markets on a concept called time-based energy attribute certificates, or TICs, which is really a way of modernizing the way that clean energy is being tracked today. If you're familiar with the markets, we have things called renewable energy certificates. Those are paper certificates that helps you claim that you actually bought that clean electron, and to make sure that not two people or two stakeholders can claim the same electron, basically. This certificate system is pretty old, and generally you see those certificates reported on a monthly basis, on a national basis. And so it's very hard to understand really the granularity of your portfolio if you rely on this old system. As we're doing 24/7, we saw very quickly that we had to move to a more real-time system and also more digital system, so that down the line we can do reporting, claiming, but also start trading and looking at new use cases with other participants. And so that's why we had launched several pilots with many partners that you can see here to really try testing this certification and tracking system, but also how do we use that new tool to help support the need for new standards and new goals that we can set up in the industries, that people can really all work together from the same definitions and from the same standards. Because by driving standardizations, we can also really amplify and focus, I would say, the effort of the industry in the same direction. Next slide, please. And a quick plug on the work that has been done on policy. I think there's really two efforts. One is really at the federal or the national level, and really how do we engage with grid operators and grid policymakers and try to push for the right decarbonization efforts at their level. But also in general, how do we align the coherent voices of all the buyers and the consumers who wants to help in accelerating that. And so that's why, as Google, we've been part of several initiatives. So first of all, as part of COP26, there is a UN 24/7 carbon-free energy compact that has been created with actually more than 60 signatories today across the energy value chain and across many different countries. And I would just encourage your team and company to look into that if you're interested in really spearheading clean energy and electricity decarbonization. This is a very nice forum where we can talk about standards and tools and best practices. In the US, we also have the Clean Energy Buyers Association, which is really focused on CNI customers and how can we unify our voices and efforts to accelerate clean energy and decarbonization in the US specifically. And then finally, there's many other people who are working on 24/7 carbon-free energy. It's definitely not just Google. Or US federal government are their own targets. And then we see many more tech companies and ICT companies stepping there. Iron Mountain was also an early adopter of 24/7 carbon-free energy, and they've been a great partner. And Microsoft, and we also got even cities now who have their own clean energy procurement efforts. So this is really a movement around clean energy and what is our role as large consumers to really create the momentum and the efforts that are needed. I think at Google, we really see this next decade as critical. And so that's why we're trying to really amplify a lot of those efforts. And with that, I think this was the last slide. So happy to take on any questions. I think I saw a few on the chat.
Now, there's a few questions on the chat. The first one is, do you plan to produce energy on premise as well, like fuel cells?
Yeah, it's a great question. We have a few on-premise energy production systems. We have some solar systems at certain data centers. We do not have a lot of on-site energy productions today. The main reason for that is our data centers are very large. Generally, it's hyperscalers, so connected at the transmission level. And so the value of adding on-site energy is really offset by the opportunity of being able to build a very large power plant, like a solar power plant or wind power plant, a few miles away and leveraging the grid. But as part of the 24/7 carbon-free energy program, we do see an interesting synergies actually between clean energy, decarbonization of our electricity, and new applications that we see on site. An example I can give you is how we've been piloting batteries at our data center in Belgium to try to test how we can, on one side, use the batteries as an additional backup, replacing diesel generators. But also when we don't use the batteries for backup, we are using them for what we call grid support or grid services. And that's really a way for us to kind of shape our load so that we can use clean energy when it's available and rely more on batteries, for instance, when we have less clean energy. So I think we see these synergies, and we're likely going to amplify our efforts on how we see the development of new technologies being available. I do think in the next decade, that's going to create a lot of opportunities to modernize our own infrastructure.
Thanks, Maud. Okay, the next question is, what is the current view of tidal energy as another type of renewable?
Yeah, tidal energy is part of our definition. I would say today, it's, from what we've seen, it's still quite early stage. And so it's been hard for us to engage on specific projects, but that's definitely one of the options that we are monitoring. Specifically, when you look at regions that are more like around island nations, for instance, where land is just constrained and you're going to need to look for like offshore solutions. So I think it's more about the maturity of the technology for us to be engaged at the right time.
Got it. All right, two more questions. Well, maybe three. Is it helpful or even necessary to form consumer consortiums as a means to leverage with energy producers to incent them to like offer the renewable energy for consumption?
Yeah, absolutely. I see those consortiums with two roles. The first one is the one I mentioned on the policy track, which is we really need to amplify the voice of consumers. And, I want to say as companies, I do think we have a duty of representing other consumers who might not have the means of having their own voice. It's really by putting the pressure on regulators and showing that there is a demand from the consumer side that we're going to see the products and the innovation on the supply side that we need. So this consortium, from my perspective, is very important. And then from a more transaction side, I do see value in aggregation and consortiums because once again, there is a lot of opportunities in economies of scale. Signing one contract for a 10 megawatt system versus a 100 megawatt system is kind of the same complexity from a legal and contractual perspective. And so you have this fixed cost that I would say is very high. And so if you can, the larger you can go, the better. And so that's why I think really aggregating, different needs and different consumers and being able to go to large scale directly is going to make things easier also. I think that's a good question.
Good. One more question. What did you mean by the needs to recognize additionality is a spectrum?
Oh, right. Yes. So I think when we started purchasing clean energy 10 years ago, the state of renewable energy was very early stage. And so there was not a lot of systems online. And so for us, our approach was to say an additional project is a project that do not exist yet and is created through the contract that we have. Today, what we see is we have more nuance there. For instance, 10 years later, we already see that some wind farms or hydropower plants are actually going to get retired because they are at the end of their life. And so one of the additionality new use cases that we noticed is repowering. And by being able to finance and purchase electricity from a repowering efforts, we can really extend the life of this capacity. And so that's where I'm coming when I say additionality is more a nuanced thing, because today it's not just about building new clean capacity, but it's also make sure that we maintain the existing clean capacity that is on the grid and that it doesn't retire. Otherwise, we're never going to be able to catch up with the load growth.
Cool. I think there are a few more questions. I'll let you address them online. Madhu, did you want to kind of do a quick wrap here? Thank you so much, Maud. Go ahead.
Thank you.
Thank you very much, Maud. Just a quick question. What is your view on how OCP can help as an industry body on some of the vision that you have articulated?
Yeah, it's a great question. Well, first of all, I think, there is an opportunity for us to drive momentum across both, I would say, operations inside the fence, as I call it, but also outside the fence. Like, what are we looking for? What is the type of consumer power that we can really leverage together to really go and make the ask to our regulators and utilities on what we need to see in the grid in terms of clean energy? Let's create together this market signal to show also that there is a place for innovation and to incentivize companies to innovate and to develop products. So I think OCP is a great place for this type of like consortium, coalition, and aligning of voices. But separately, I would also really be keen on thinking about how do we rethink our data center approach or operations principles to really be better steward of the grid, I would say. Traditionally, we've seen data centers as load that have to happen, and the grid just has the duty to deliver the electricity to us. But I think today, based on where we are with all the challenges, the energy crisis, we have to recognize that it's really a bilateral relationship, and what can we do to really be better and more flexible on our operations and support the grid and the decarbonization efforts from the grid as much as we can.
Thank you very much, Maud. That was a really great presentation to wrap up our 3-hour Tech Talk. Appreciate you joining us and articulating your vision. Thank you.
Thank you, Madhu.
Thank you. Yeah, Archana, I can wrap up. I think for me personally, it's been a very engaging 3 hours. Enjoyed every minute, all the questions, all the presentations. So I want to thank all the speakers for putting all the work in and all the enthusiasm and effort and insight that they've shared with the community. Going forward, I think Archana, myself, Justin, and Brett, my co-lead, we've discussed a potential work stream in this area for data center sustainability under the data center facilities umbrella, maybe jointly sponsored with cooling environments because of the heat reuse aspect, as well as the sustainability group, which is already active in OCP, which has a broader mandate. So that's something Archana and the leads are going to pursue in discussing. We welcome your interest, as assuming we are successful in kicking that off. We really welcome your proactive interest to join that work stream to contribute to the space. I think maybe one couple of items that really stood out for me is maybe leveraging OCP Ready around some of our sustainability metrics. That's one thing that stood out to me. And then another comment was about quantum computing and the cryogenics needed at the facility level for quantum computing. There was a question, and that might be an interesting area for, beyond the 5 or 10 years, looking ahead 15, 20 years. There might be an area for DCF to also have some, fun brainstorming and thinking. So
actually, we're already talking about it in our future technologies symposium. It is one of those things that we're talking about in terms of beyond AI, ML, and what are we doing in quantum computing. So if you are interested in that, there will be sessions, and the call for papers for the Future Technologies Symposium is open right now. And this would be an excellent topic to bring up there as an abstract or a paper, and just talk about a use case like this, right, for the data center facilities. So I think that if we can get that ball rolling, I'm not sure who placed the question in the chat, but whoever it is, please look up our Future Technology Symposium and submit an abstract there. Madhu, you're right. You're absolutely right. The leadership has been talking about a sustainability work stream focused on the facility, whereas our sustainability initiative is really focused on the systems and the rack and the components within the rack, within the data center. And then our heat reuse folks are looking at it from a cooling perspective. So we're kind of all a little bit touching on sustainable solutions and sustainability in different ways. But I think that bringing it together here under data center facilities might be the most optimal place to be able to take all of these bits and pieces together and provide some guidance for OCP Ready, as well as those operators like KAO and Google with their own data centers, right, to be able to help us and give us their best practices and share with us, what we should be doing as we're looking at data centers in the future. So as Maud mentioned, consortiums are really good, communities are really good, and we're already having that discussion. So we would really invite everyone here to come join us, attend the next data center facilities project call, and please flood Madhu and Brett and Justin with your ideas, because I'm sure that they're looking for as much help to get this started. This was just the genesis, and I think that we're ready to take it on. So couple of parting thoughts. One more time, the session here was recorded. So if you have colleagues or friends that are interested in this but could not attend today, it will be on the OCP past events page. The recording, the chat, and the slides, starting to put some of them up already. So come back in a day or two, it will be up there and you'll be able to access it directly from the OCP website. Our OCP Summit is also coming up October 18th through the 20th in San Jose. It'll be an in-person summit. Call for papers and abstracts are open for that. Data center facilities has a huge track there, so we would love your inputs there to continue the conversation and to share some of those ideas and best practices with us. So with that, thank you again to Madhu and Brett and Justin and the rest of the team for putting an excellent lineup for you today. For all of the speakers, Gerard, Maud, Rob Bunger, Cosimo, the Alpha Laval team, everyone, thank you so much for taking your time today. I know it's late in the UK, so really, truly appreciate it. And for all you audience folks, thank you so much again for being here. Our next Tech Talk continues next week with cooling environments, and just the heat reuse topic that Cosimo mentioned will be discussed there, along with other cooling environments like immersion, cold plate, door heat exchangers, and you name it. So thank you again. Have a great rest of your day.
Thank you, Asna.
Or evening. Bye-bye.